the value of the components. So for C1, that's 100 mu. C2, also 100 mu. For C3, that's 22 mu. For R1, that's 25.5 K. R2, 25.5 K. R3, this one is 2.32. And R4 is 1.02 K. R5 is 10.5 K. And for the value of the V in and V out sine offset, 0, 0.1 N, and then 1 G. Then for VCC, that's 12 volts. Then we also have to label VB, VC, and VE. So here, that's where VB will be. Here, VC, and this is where VC is, and here lies VE. So unlike the previous circuit, wait, I'm gonna move that. Unlike the previous circuit, C2 isn't connected to the point VE. Okay, let's check. Alright, all things set. Oh wait, value of R6 is 2K. Then I did simulation command, same as always, the standard T01M, and that should be our startup. Let's put that here, and voila! This is our common emitter amplifier with no load. Oh wait, no. I'm looking at the other one. The first one is it with load. My mistake. This one's with load and no bias. Oh no, bypass. Mistake. And that's it. Okay, one correction. This Q1 should be mat-02. That's in accordance with the list. This list. It's important to specify the part number of component Q1. Other than that, that's common emitter amplifier with load and no bypass. For the final circuit that we're gonna do it's gonna be called the common base amplifier with bias and bypass. So it's pretty similar to the one we did, the first two that we did, but there's a couple differences that sets it apart with the rest. So again, we start with the V in, zooming out, fair, connecting it to C1. So that's where our C1 is. So instead of connecting it upwards, we're gonna go downwards, then flare. So notice that new connections are made here. Let's see. Going straight, then up. That's where our R1 is. Then go down, and that's where our R2 is now. Here, this is where our 3 is. There we go. Then R4 is as usual. R2, R4. So there's your R4, and we're looking for our NPN. Let's do series with this. Connect those lines together. There we go. Then let's go to R5. Going down. There we go. There's our R5. Let's connect this one to that line. Where's C2? Okay. C2's here. Let's go down. So that's where our C2 is. Now connect the rest. There we go. Then moving on to the other part. Where C3 is. Let's do that. That's where C3 is. Third capacitor. As usual, there's our V out. Then R6. The last resistor. Then this is where our VCC component is. Now we'll just have to. There we go. So next is labeling the parts. So This is where VB is. VB. This is where VC is. And this is where VE is. Oh, and before I forget, I'll label where V out is. This is where V out is. This is VN. V out. Okay, all set. Now let's plug in the values listed in here. So Q1, this is the part number is MAT02. First capacitor is 100 nanofarad. Second one is the same thing. Third one is 22, or one is 25.5 kilograms. R4 is 1.02 kilo ohms. Oops. 3 R2 is 25.5 kilo ohms. 2.32 kilo ohms. R5 is 10.5 kilo ohms. This one is 2 kilo, and this one is 12. This one would be 0.1 M and 1 G. So let's check. Here we go. It's the circuit here. Okay, now let's edit the simulation command to our usual settings. And label this accordingly. There you go. Hold on a minute. bypass. Now this is the figure for this one. You can get the voltages from this this circuit. Let's open. Oh, so these are the circuits that you'll need for this experiment.